Massive enterprise CRM systems operate on a core paradox, balancing the need for broad workflow access against the requirement for strict data privacy. To perform basic daily functions, standard users require constant, broad access to structural operational records. Sales representatives need to query account lists, and support agents must review extensive case histories to do their jobs. However, these necessary operational records inherently embed localized, highly sensitive data points, such as an employee's exact salary, personal identification numbers, or private financial metrics. Salesforce introduces field-level security, or FLS, as a granular mechanism to resolve this tension. It isolates specific fields, maintaining their privacy while keeping the rest of the operational record functional. By controlling access at the individual cell level, FLS prevents necessary operational workflows from resulting in unintended data exposure. This is an object in the Salesforce architecture. It acts as the foundational database table, serving as the broadest container for incoming data. Within that broad container lives the record. This isolated row represents a specific individual data entry. Under the standard access protocol, an administrator grants a user baseline permission to query and read this specific isolated record. The structural consequence of this baseline access is broad exposure. Natively, standard record access exposes every single localized data point, or field, embedded across that row. If just one of those illuminated fields contains legally restricted information, the entire record becomes a compliance liability. An administrator could create an entirely separate, isolated object just to house that sensitive data. But doing so is architecturally inefficient and rapidly creates fragmented, disconnected data silos. The system requires a localized restriction mechanism that can reside within an otherwise accessible container. The difficulty lies in enforcing this localized restriction without inadvertently shutting off the user's ability to utilize the rest of the record for their daily tasks. To solve this, administrators must isolate privilege at the microscopic cellular level rather than the macro record level. Securing a multi-tenant environment requires stripping away a deeply held assumption that record access guarantees total data visibility. Field-level security operates as an absolute system constraint, applied directly to individual data cells, totally decoupled from the row itself. FLS calculates data access independently. It relies on a secondary logic pathway that routes directly to the isolated field block, entirely bypassing the user's object or record-level permissions. The operational result is precise. The user successfully queries the parent record, but FLS intercepts the specific sensitive data payload before transmission. As a sovereign override, FLS enforces visibility restrictions even when the user possesses valid permission to view the parent row. To control this behavior, administrators use FLS to apply one of three explicit states to any field in the system. The first state is hidden. Under this constraint, the platform entirely redacts the data from the user's view. It completely strips the restricted information from the active data payload. The second state is read-only. Here, the user can view the data, but the database rigidly rejects any commit or write attempts. The final state is editable, which grants the user full baseline read and write privileges for that specific cell. By applying this matrix of states, organizations can curate highly specific, customized data views from a single, unified source record. FLS transforms a static database row into a highly dynamic, user-specific data matrix based on rigorous mathematical constraints. Managing these localized field constraints across thousands of enterprise users requires centralized configuration logic. The primary mechanism for establishing this baseline security is the Salesforce profile. This diagram illustrates how the profile operates. It acts as the strict baseline identity and security template assigned to a user upon creation. Administrators configure the foundational FLS states entirely within this profile logic. But enterprise operations are rarely that rigid. Operational exceptions occur constantly, requiring temporary or role-specific access upgrades without altering the baseline profile. To handle these exceptions, Salesforce employs a secondary configuration mechanism, permission sets. Think of permission sets as modular, additive privileges strategically layered on top of a user's base profile. A permission set can upgrade an FLS state, elevating a field from hidden to read-only or editable for just that specific user. This reveals a foundational rule of Salesforce architecture. Permission sets can only expand access states. They can never restrict a baseline profile state. The interplay between strict profiles and additive permission sets creates a precise, scalable engine for dictating FLS across complex organizational structures. To implement this engine properly, administrators must abandon a common misconception, the UI illusion. This split screen illustrates the UI illusion. It is the false belief that simply removing a field from a visible page layout secures the underlying database information. On the right, raw terminal code successfully extracts that exact same data from the backend. If security relies solely on superficial UI layout filters, users can trivially bypass it by querying the platform directly via alternative vectors. As this diagram shows, field-level security prevents this bypass by enforcing restrictions at the architectural root, far beneath the user interface layer. From this root level, FLS simultaneously regulates the platform's 4 primary access vectors. The first vector is the standard user interface. FLS dynamically scrubs the restricted field from rendering on any page layouts. The second vector is reports. FLS prevents the restricted data from populating in any system-generated reports or dashboards. The third vector covers custom Apex code. FLS restricts custom backend programming from unintentionally exposing the data to an unauthorized user context. The fourth and final vector is APIs. External system integrations querying the Salesforce API are strictly bound and blocked by the integration user's FLS configuration. Because FLS operates at the deepest platform level, it guarantees omnipresent enforcement. It makes unauthorized data extraction mechanically impossible across all vectors. When we map these technical mechanics back to the real world, the operational consequences for enterprise organizations managing personally identifiable information become absolute. In modern regulatory environments, failing to securely isolate localized sensitive data within broader operational datasets is a critical legal liability. A proper, rigorous implementation of FLS serves as the foundational mechanism for proving data privacy compliance within a multi-tenant CRM. It takes theoretical organizational security policies and transforms them into mathematical constraints permanently locked within the database architecture. Field-level security provides a mandatory architectural layer that protects data integrity and shields the organization from exposure.